Hello, I'm Karen Bozak, and I'm the Systems Integration Functional Area Manager in the Orion European Service Module Project Office at the NASA Glenn Research Center in Cleveland, Ohio. Some of my own pandemic hobbies include crafting with my Cricut and chasing my two toddlers around local parks or the home office. I'd like to thank you for being a part of SWE21, the world's largest conference for women engineers. As we transition from last year's pandemic lockdowns and their inherent challenges, the SWE21 conference is part live and part virtual. As a virtual attendee, you might be watching this presentation on how to return to the moon during a pandemic by yourself. But please know that as a SWE member and as part of NASA's Artemis generation, you are also connected to a very large community that supports you, supports diversity, and is here to help you succeed. So with that, I'll embrace this year's conference theme of Aspire to Inspire and begin our presentation.
Following today's session, you should be able to explain the Artemis program to the public, including the mission objectives and goals and the systems that will enable exploration beyond low Earth orbit. Also, relate the roles and responsibilities of each panelist to the Artemis mission in terms of their individual contributions to a particular system or element of the mission architecture. And identify innovative strategies and approaches that are enabling to Artemis. In Greek mythology, Artemis is the twin sister of Apollo and the goddess of the moon. NASA's new exploration program is named after Artemis, and through this program, NASA will land the first woman and the first person of color on the moon, where no one has been before, the lunar South Pole. When the Artemis astronauts land, they will step into the future, bringing all of humanity with them. With the Artemis program, we're going to the moon differently than we have in the past. This time, our focus is to learn to live on other planets and to prepare for eventual human exploration on Mars. With the Artemis program, NASA will put the first woman and the first person of color on the lunar surface and work to build a sustainable presence there and in lunar orbit. Pictured here are some of the elements as part of NASA's Artemis program. From left to right is the Space Launch System, the Gateway in a lunar orbit, and lunar surface systems. With these elements, NASA has very exciting near-term exploration plans. Pictured on this chart, moving from left to right, some of the initial landings on the moon will start later this year with the Commercial Lunar Payload Services, or CLPS program. Through CLPS, we'll be able to deliver small payloads to the moon, expanding our knowledge through research and scientific technologies. Next, with Artemis 1, that marks the first launch of our Space Launch System, or SLS, and Orion together. While it's an uncrewed test flight, it will test a lot of the capabilities of the system and prepare it for future human exploration. And speaking of future human exploration, Artemis 2, right afterwards, is the first crewed mission of the SLS and Orion vehicle. Artemis 2 will take the crew to a lunar orbit. Also exciting and coming up is the Gateway's first launch to a near rectilinear halo orbit, or an orbit around the moon. The Gateway's power and propulsion element and habitation and logistics outpost will launch together, enabling science operations to begin in a lunar orbit. Following the Gateway is the initial human landing system delivery to lunar orbit. And next is Artemis 3. That is the first crewed mission to the lunar surface. Beyond that, NASA has plans for future launches to extend our surface mobility capabilities, such as the delivery of a lunar terrain vehicle to the lunar surface. So even though we're in the middle of a pandemic, NASA has been preparing for Artemis 1. Again, this is the first integrated test flight of NASA's Orion spacecraft and the Space Launch System that will launch from the Kennedy Space Center. While this maiden voyage will fly without crew, it is designed to push the systems to their limits and also to return safely to Earth validating that the system is ready, and ensuring safety for future crewed missions. Building, launching, and flying the system is challenging, again, especially during a global pandemic, and it requires a highly skilled workforce, enables growth for small businesses, revitalizes communities, and inspires our nation and world. Artemis 1 is targeted to launch in late 2021. With Artemis 2, this will be the first crewed flight of the SLS and Orion. On board, up to 4 astronauts will return to the lunar environment for the first time in more than 50 years. This will be our Artemis generation's Apollo 8 moment, during which the astronauts aboard Orion can capture the full globe of the Earth from afar as a backdrop to the moon. Artemis 2 is targeted to launch in 2023. The first commercial human landing system in history will take astronauts from the lunar orbit to the surface and back again. The capability of the human landing system is that it will be able to carry 2 crew on this journey to the lunar surface and back to lunar orbit. While on the lunar surface, it serves as a habitat for the crew and also houses equipment for different surface activities, such as moonwalks, sample collection, and scientific experiments. The Gateway will be humanity's first outpost in a sustained lunar orbit. Over time, additional elements will be used to build up the Gateway, increasing mission durations and science capabilities. And those scientific capabilities include a wide array of internal and external experiments that will help us to learn about living and working in deep space. Gateway is a collaboration with international partners, and as such, it enables a truly sustainable lunar presence. Some of the international partners contributing to the Gateway are shown here, such as the Canadian Space Agency, or CSA, the European Space Agency, ESA, and the Japanese Space Agency, JAXA. Through Artemis, we have exciting plans for a sustained presence on the lunar surface through a steady cadence of missions and a robust infrastructure. Some aspects of that infrastructure are pictured here. An unpressurized rover will provide extended exploration range and mobility for 2 suited crew members on the surface. There's also plans for a pressurized rover that will even further extend the exploration range. And also in the backdrop here, you see a foundational surface habitat that can also enable longer duration stays. These larger elements are also supported by smaller logistic landers. And through all of this, we will enable science, technology demonstrations, and operational analogs that will prepare us for human exploration of Mars. So now that you've heard about the missions and the elements that make up the Artemis program, it's time for you to meet some of the people. I'd like to introduce you to my co-host, Deboshri. Deboshri Sadhukhan works at NASA Glenn Research Center as a Deputy Project Manager for International Space Station Payloads. She's also a Safety and Mission Assurance Lead for a radioisotope power systems project. And in her spare time is an aspiring amateur chef and fitness kickboxer. Deboshri, please introduce the panel for today's session.
Thank you, Karen. I'm happy to introduce our 3 amazing panelists today. First, we have Erika Alvarez. She's the Systems Engineering and Integration Manager for the Advanced Exploration Systems Division, focused on Artemis integration for lunar landing missions. She has a Bachelor's of Science in Aerospace Engineering from Penn State University. She loves puzzles and video games for her 8-year-old son. Next, we have Nicole Smith. She's the Deputy Director of Technology Demonstrations for the Space Technology Mission Directorate. She has a Bachelor's of Science in Aeronautics from Miami University, a BA in Mathematics and Statistics from Miami University, and a Master's of Science in Aerospace Engineering from University of Cincinnati. And she is the woman in the pink hard hat in front of the Super Guppy on all of the NASA sites. And last, we have Helen Vaccaro. She's the Gateway Safety and Mission Assurance Systems Engineering and Integration Lead. She has a Bachelor of Science in Aerospace Engineering from Penn State University, and she loves hiking, and the best trip she had was a backpacking trip to Machu Picchu and Peru. Wow, amazing. So let's start with the first question. So please describe your current position at NASA, your role and responsibilities, and how you've been able to contribute to NASA's return to the moon as part of the Artemis program in your current position. Let's start with Erika.
Thank you, Deboshri. So just very quickly, to summarize, I do the systems engineering and integration management for a division that's responsible for executing the Artemis missions that start with the lunar landing. So primarily we integrate with the human landing system, our gateway, which will be our orbiting platform in cislunar space that's orbiting around the moon, as well as our suits, our rovers, and all our ground systems that we're going to be putting on the lunar surface. So my biggest role has been establishing basically the STNI, which is how we do the integration across all the programs, the key requirements that drive the mission, and then a lot of the mission planning in terms of what is it that we actually want to execute as we conduct these missions, and starting to put together all the products to be able to facilitate that work. So that's our group's main contribution, is making sure that we establish those future missions, what they're going to look like, all the objectives, the cadence, and then also establishing the manifest for those.
Great, thank you. Nicole?
Yeah, hi, I'm Nicole Smith, and I'm the Deputy Director of Technology Demonstrations in Space Technology Mission Directorate at headquarters. So Space Tech's charter is to develop transformational technologies that'll help enable new science and human exploration missions, while also promoting commercial space industry growth. So we, as a directorate, develop technology from early stage research that's in the lab, many of those working with universities and so forth. And then we grow the technology all the way to the point where we demonstrate it in space, often large scale demonstrations. And that's my area primarily. So I work with the technology demonstration program, which is based in Marshall. And as part of my job, I coordinate with other technology programs within Space Tech, work with the TDM program, and ensure that the projects under TDM really get all the support that they need. And also work with other mission directorates within NASA, such as Human Exploration and the Science Mission Directorates, work with other government agencies and commercial partners to ensure that we're all in lockstep on the types of technologies that we are proving out that will be able to be used to support future science and human exploration missions.
Thank you, Nicole. And Helen?
Hi, everybody. I'm Helen Vaccaro. I'm the Safety and Mission Assurance Systems Engineering and Integration Lead for the Gateway program. So I lead a team that kind of manages the safety and mission assurances products and processes, any of those things that deal within the systems engineering and integration area of the Gateway program. So we perform risk assessments on different systems integration issues. We evaluate any technical issues that have come along during the design process. And I've actually only done this position for the last couple of months. Prior to accepting this position, I was the Gateway Program Integrated Hazard Analysis Lead. So I led a team that developed the system safety analysis for the integrated Gateway vehicle. So we evaluated the design to see how we can prevent hazards from causing loss of the crew that we'll have on board the Gateway, as well as the loss of the spacecraft when it's uncrewed.
Okay, great. Thank you, Helen. Some amazing positions that you guys hold. So for our next question, can you describe a specific challenge that you've faced associated with achieving the Artemis program's ambitious goal to land the first female and first person of color on the moon by 2024? How did the global pandemic impact this specific challenge, and how have you leveraged innovative strategies or approaches to overcome this specific challenge? Let's start with Nicole.
Well, I've had a few different ones. So just to start really quick, personally, so I've had 2 job changes during the pandemic, which starting a new position is always difficult when you can't meet with folks face to face. So we had to get really good at virtual settings, just like where we're at now. But in my previous job, so 2 positions ago, I was a project manager in charge of testing the Artemis 1 crew and service module out at what is now the Neil A. Armstrong test facility in Sandusky, Ohio. And we finished up the testing in March of 2020 and flew the spacecraft home to Kennedy. I think it was March 25th of 2020. So you all know what was going on during that first quarter of 2020, where we were hearing about COVID and what is it and how do you spread it and everything. All the information was drastically changing. And meanwhile, we had up to 150 folks from all over the place in our test facility. Some of our international partners from Europe, friends from Denver and Florida, engineers, technicians, et cetera, people traveling back and forth. So, my challenges for that were to, how do you keep the test program moving forward? How do you keep your staff safe and healthy? How do you rapidly change your processes and procedures as you're learning all of this information about a global pandemic? And, and we had to make some really tough decisions at the time because, the state of Ohio was shutting down around us. Other states in the nation were shutting down. We were struggling to fly it back. We had to have support from the National Guard and the Air Force. And so, making sure that we could get that support too. It really took a lot of extra effort and extra coordination to be able to do all that. And I remember trying to make a decision. We were like, do we fly it back or do we shelter the spacecraft in place? And we were like, oh, it could sit here for 4 months and there's nobody here to really, monitor it and think about that. That was almost 18 months ago now that we were having those discussions. So that was a really fascinating challenge. It took a lot of quick thinking on our feet, a lot of coordination, and a lot of trying to see, the next hurdle that you're trying to get past without knowing what the next hurdle really was. So it was very interesting. Anyway.
Thank you, Nicole. I can't imagine having to make those kinds of decisions under such very difficult circumstances. How about Erika?
I would say, like Nicole, when we started the pandemic, I was actually working as part of the Human Landing System program, and we had just stood up a brand new program to work with our commercial partners to start the new lunar lander development. So I had a good amount of time to set up the whole team that was going to do all the technical insight on the lander. When I was offered this opportunity to come work at NASA headquarters to do this higher level integration for this new organization, in our Advanced Exploration Systems division, where we're doing all the integration across all the Artemis programs. One of the biggest challenges as part of doing that is that in me supporting this NASA headquarters role, I'm actually located in Huntsville, Alabama at Marshall Space Flight Center. And so I had to stand up a new team. This team is really across the country, and we even have global participants from our international partners that are in other countries, trying to stand up a team that would integrate 3 existing programs like the Space Launch System, the ground system down at Kennedy, the Orion spacecraft, and now bringing on the Human Lander System, the Gateway, as well as the rover, and the suits, which were just starting, trying to bring all those people together that were not co-located in one area, that were all spread across all different parts of the country, different time zones, and me trying to stand up a new team. I think it was interesting to see how much I had to really reach out into previous networks that I had built on previous programs, and working with all these different communities and all the NASA centers and trying to bring the best talent that we could bring to start this new organization. I think also for people to meet each other and to start to form a new org and a new team, it's challenging when everybody's working from home and you can't be all together in the same place, and you can't use whiteboards, and you can't do as much brainstorming as you normally would do face to face. I think having those important discussions, at least what we've learned, is that these cameras really help facilitate, how we talk, how we communicate with each other, how we could see and read just with body language, with being able to read facial expressions. it's really important to making sure everybody's happy and understood and their thoughts are being shared and that we're getting all those best thoughts and putting our systems together. And I think also, once we were able to start to open up travel a little bit and meet each other face to face, it was so surprising how we would say, oh my God, you're so much taller than I thought, or you're so much different than I pictured you because I've been seeing you for days and days or just talking to you on the phone. So I think the challenge was just setting up a new organization and having everybody make those personal bonds while we're in a pandemic. It was hard, but it was also easy because we were all in the same boat and we're all at home and we're all working from home alone. And we want to feel a sense of bonding and not feel like we're all home alone and we're in it together. And that's what actually formed our bond, which is now actually stronger than it would have been if we were all at different cities and different centers and feeling those different barriers. So that was kind of my experience, Deboshri.
Can I just tag on to that, Erika? Because I love that you brought that up about trying to set up a new team and the cameras. So I worked on programs for a long time that had, different organizations across different time zones and whatever. And so we were always on telecons. Like usually it was a telecon and then, some sort of thing like Skype with charts, right? So you didn't see faces and things like that. It's actually been really positive, I think, during the pandemic that we are all using cameras and now we are using Teams. And so we have this sort of video platform that we can actually see each other. I agree. It's actually better for those of us who have been sort of remote from our programs for a long time. I think it's a really nice, it's like a silver lining, I guess, is that we can see each other's faces and have an opportunity to meet. And it's definitely enabled us to I guess stay closer together too. It makes me happy when, former team members reach out just to say hi, and I try to do that with them as well, just to touch base and see how we're doing. So thanks for bringing that up because I think that's a really good point.
Yeah, there's no more candy dish. Like I can't go to somebody's office and sit down and eat their chocolate. I do miss that. But I do like being able to, like if my son walks in or if he sees someone like Nicole's cat walk through, on the video, you can get this personal connection that you didn't have before in the office, right? And people could dress more casually. I get made fun of because I wear headbands all the time. And it's a very casual look, or sometimes I wear a Yankees baseball cap. And not if it's an important meeting, but sometimes I do that and then people go, oh, are you from that area? So there's some nice parts of it.
Thank you, Erika and Nicole. Great points. I also really liked how you said that we were all in this together, which is very true. We're all in the same boat, working from home and, kind of struggling together, as they say. Helen, do you have anything to add?
Well, I'm just impressed by Nicole and Erika, who both changed jobs too during this pandemic. I mean, I do think it's a testimony to how great NASA is at adapting and being flexible and changing in the situations, right? One of my biggest challenges before the pandemic was for Gateway program. We've got this whole commercial approach to the first element, the power and propulsion element. That's going to be the first element of Gateway, and we're trying to take a commercial approach where we use existing reliability. We're trying to leverage that existing reliability of the power and propulsion element, and so we're trying to change it as little as possible. So we're trying to rely on the design and construction standards of that element, and so it's been difficult because it's something we've never done before, right? For human spaceflight, we have our NASA specific standards and the way that we've done human spaceflight, but now we're trying to use this commercial approach, and that's something we've never done before, and it's difficult. And then you run into this pandemic where we're trying to build this relationship with this commercial company, and use their industry standards. And we can no longer go out there and visit them. We can no longer go and see the types of things that they're doing, their standard practices, and that was a really big difficulty. But I mean, I think NASA, as I mentioned, has been amazing at really immersing ourselves in this virtual with the Teams environment and learning how to build relationships remotely, and building that trust with these commercial partners, and I think that we've done a really great job at that. And it's amazing to hear all the folks that have changed jobs and, how do we do this? How do we build relationships? It's those little nuggets of of having your picture be somebody somewhere that you've gone or somewhere you've been or with your family and things like that. That's the way that you can build those relationships remotely. And NASA's done, I think, a great job of that.
Thanks, Helen, and I couldn't agree more. Okay, for our next question, can you talk some of the innovative technologies that NASA will need, not only to enable humans to return to the moon under the Artemis program, but to also enable eventual human missions to Mars? How do you see the Artemis program striking a balance of the speed to return to 2024 with sustainability and safety? Let's start with Helen.
All right, so that power and propulsion element I mentioned earlier is using solar electric propulsion, which I'm super excited about, right? This new technology that we're using, but it from my position of making sure we keep the crew safe and the spacecraft safe, how do we make sure we identify all the unique hazards to that technology? We want to make sure that we're keeping the crew safe and the vehicle safe. And we need to make sure we analyze that technology to make sure we identify the hazards, and then we can adequately control them. And then once we do that, we've got a good handle on it, make sure we understand what residual risk we have with that new technology, because it's something we haven't used before. And so I think the solar electric propulsion, it's really exciting, and we're learning more and more about it. But I think we're getting a handle on all the unique hazards. But that's, I think, the most important from my perspective. Thanks,
Helen. Nicole, anything to add?
Yeah, thanks for bringing that up, Helen, because that was actually one of my talking points for this section. So the solar electric propulsion is actually being developed and tested by my organization, TDM. And so, we're really excited about flying a brand new technology on the Gateway power and propulsion element. So you bring up, how do we assess the safety and the hazards of it? Yeah, absolutely. And our job is to develop that technology and then do a bunch of qualification testing on it, long life testing, et cetera, to make sure that it runs exactly the way we think it should, and that it'll be safe for flying it on Gateway, which of course the astronauts will be on, right? So that's a really cool segue. Thank you for bringing that up. So I don't think I mentioned this when I was doing kind of my introduction about my job. So I started my new position in the beginning of June of this year. So I've only been part of Space Tech for 3 months, but one of the technologies that was, I guess, being demonstrated, which is part of my organization, right when I started in Space Tech, was called MOXIE. And maybe some folks have heard about it. It flew, or it's actually still up there, on the Mars Perseverance rover, and it's successfully creating oxygen from Mars's predominantly carbon dioxide atmosphere. And I think it's run 4 times, and we're in the process of scheduling a 5th run for it. So this is the type of technology that's really cool and really exciting when you start thinking way in the future, like, how do we support humans going to Mars, right? Because you cannot necessarily take all the things that humans need to support their life for that long of a journey. You need stuff that can make oxygen, water, et cetera, in situ for them. So that's one really cool technology that we're working on. And there's a lot of other ones too, right? So, we're working on power systems for the lunar surface, including a 10 kilowatt class fission power system. We're working on way better communication systems like laser comm, which can provide 10 to 100 times better data rates. So we can get more science, more data from space, whether it be the moon or et cetera, to Earth in a single downlink. We're doing on-orbit servicing and refueling with the OSAM missions. Those are really neat. We're going to be proving out, like, can we transfer propellant to an existing satellite, for example. And then we're also doing on-orbit manufacturing as well. So there's just lots of really cool technologies that we're working on as part of my job to help with human exploration, both for the moon and then looking farther in the future to go to Mars, since it's such a long trip.
Some exciting technology. Thank you, Nicole. Erika, you have anything to add?
No, I was going to add, sort of along the lines of what Nicole and Helen mentioned, these lunar missions, these Artemis missions are going to be the first time that humans go to the South Pole. We've never been to the South Pole, and most people don't know this, but the conditions are very different from our Apollo missions. there's a lot of darkness, there's periods of darkness, there's also very cold environments. And some of what we're trying to do is actually go investigate permanently shadowed regions that have never seen light before. And so we are going to have systems like our lunar terrain vehicle that will be remotely operated and will be working there 24/7 upon landing and performing science. And they have to be able to survive the night. And in surviving the night, they have to be able to show that they can maintain enough power, maintain charged up enough that they can recharge again, start up again, continue moving, continue on their mission, maintain some communications, as well as what Nicole mentioned. There's a lot of thermal conditions. And so as part of that, we are looking at, leveraging some nuclear surface power, other things that we can have there as charging stations. So I would say, a lot of what Nicole said, and also the ground comm, looking at setting up a comm network just on lunar surface is a big part of the technology work that we're doing today. So I would echo both of what Helen and Nicole said is important to our campaign.
You think Wi-Fi is tough in your own house, imagine it on the lunar surface, right, Erika?
Exactly. And imagine trying to communicate with, eventually in our Artemis base camp, we'll have the lander, we'll have a terrain vehicle, we're going to have a pressurized rover, we're going to have a habitat, and we're going to have suits. You're talking about being able to communicate with at least 5 different things at one point in time, and all sending all that data back. So all that's going to be critical, as well as having the gateway be a key part of our communication infrastructure too.
Thank you, Erika, and I agree with each and every one of you. I also liked how you mentioned that the Artemis missions are different from the Apollo missions, and not many people know that. So I'm glad you brought that up. So for our next question, all of you have held positions prior to your current roles where you have also contributed to Artemis. Can you share with us one of your previous NASA positions, highlighting how you were able to contribute to NASA's return to the moon, and how did that specific position prepare you for where you are today? Let's start with Erika.
So I know previous to this position, I mentioned that I worked on the human landing system, which obviously was very instrumental in me being able to kind of piece together what we're doing for Artemis. But prior to that, I was a lead systems engineer for the Space Launch System, which is kind of the logo, behind you there, Deboshri, which was getting close to its Artemis 1 maiden flight now. And being able to do the integration on all the systems engineering across the rocket, and trying to understand how to piece together not just all the internal systems, and how to make sure that all of them are maintaining proper interfaces, good requirements across the whole stack, but also working with other programs, like working with Kennedy Space Center that supports the ground, like our mobile launcher in our vehicle assembly building, and building good interface requirements with them, as well as Orion, which is the capsule that's on top of the Space Launch System. You start to realize how a big part of this job is looking at the other person's perspective, and understanding that they also have a schedule, they also have milestones, they also have objectives, and how do we not impact them as much, but at the same time, make sure the whole system is integrated. I think working across those 3 major programs that were all running in parallel for many years really helped prepare me now for bringing on board a lander and the gateway and all those surface elements for the lunar surface. How do we establish those agreements, those partnerships, those relationships, those trusting networks that you need to solve the tough technical problems? Who do you call? Who do you bring online? Who do you ask for help? I think that's helped really prepare me to take on this role, because you kind of have to have that whole network. At the end of the day, it's all about the people. So that's one of the biggest things. If I were to give people just career advice, if you're moving from one job to another, you don't have to know at the end where you want to end up. But if you're something that you really like about what you're doing now, which I really love doing the integration, when they asked me to come do this new job, I said, well, it's just the same thing, just in a different scale. But for the most part, it's a small community. It's usually close to almost the same people. So it gives you that confidence to be able to take that next step,
Thanks, Erika, and I completely agree. Nicole, anything to add?
Yeah, for sure. I would agree with a lot of what Erika just said. So over the course of my career, I've also been a systems engineer. I was talking earlier about being the project manager for the testing out at what used to be Plum Brook Station, and testing I think we did 5 large scale, so module or even spacecraft level tests out there. There's so many different systems that you're dealing with. You're dealing with facility systems, the spacecraft, all the GSE that goes with it. I was manufacturing things, in charge of that, and then coordinating all of these different teams. And it was, I learned something new every single day, even at the end, even after 7 years of working on that particular project and doing that testing. Before that, I was the lead systems engineer for the Orion service module. And I always used to tell people that a lot of it was about making sure all of the systems on the spacecraft played nicely together. And the unspoken part of that is making sure that all the people also play nicely together, right? So enabling communications. It's really easy to look at requirements. It's really easy to look at the verification of those requirements. The integration piece that's in the middle is sort of the fluffy intangible, and it's getting people deployed who can think about the whole spacecraft as a system, and they may be in a meeting saying, hey, this valve requires a comm rate to be commanded at a certain rate, but we're not necessarily giving it that rate over here. So what do we need to do to make this work out? So, and prior to that, I was in the space station program office as the electrical integration engineer there. And I also, this was down at Johnson Space Center, and I also worked in mission operations as a systems instructor for astronauts going to space station. So you'll never learn as much about a vehicle as if you are tasked to figure out how to break it and then fix it again. So for me, I think I learned a lot about being an engineer when I was the systems instructor. And I'd say, okay, I'm bringing down an entire power channel on the space station. And then I would have to tell all the other systems what was going to break or go offline of theirs when I cut power to it, right? So I would have to be able to look at the whole entire architecture and say, okay, this is what's going to happen, and then this is how we get out of it, right? And it was always really exciting to kind of trip up the crew or the flight controllers that we were training for a few minutes, but it was even more exciting to see them figure out what to do and how to fix it. So that was really amazing. So anyway, my career has been kind of all over the place. And, having all of those really neat experiences in engineering, in mission operations, and in program management has really helped me just kind of get a really wide range of, how does a vehicle operate? How does an architecture operate? And have a huge appreciation for folks who have expertise in a lot of different areas, whether it be, someone who's doing, an advanced materials analysis, or, the technician at work who's welding aluminum for our, support stand, to go in the test chamber. Just, it's been really great to work with so many talented people, learn from them, trust them. And I would just tell anybody that, as you're going through your career, listen to everybody. Probably listen more than you speak, although I'm rambling on. So, I'm not taking my own advice. And, don't be afraid to ask questions. Be confident in what you know. And it's okay to not know everything, because nobody knows everything. So that's my best advice, I think.
Thanks, Nicole. And I can definitely relate to a lot of what you said. Helen, do you have anything to add from your experience?
Oh, I was having flashbacks when Nicole mentioned throwing failures at stuff. My first career out of college was as a space shuttle flight controller. So I was in mission control, and I came in as a flight controller. You're operating the vehicle, and I came in at such a point where the space shuttle had been flying for so many years, so it had already been designed and had been operating for a long time, right? So you're sitting on console, and when something happens on orbit, you're having to address those problems, and figuring out what went wrong, what failed, right? And I feel like that position has helped me, now with Gateway at the very beginning of the spacecraft that we're designing. How can we design something so that it's successful? How do we not make sure we don't have those failures? Learning from that, but from the ground floor, that we're designing this vehicle, and I think it's helped me get where I am today to help us have a successful lunar mission. If we're talking about advice, I would say, always be open to new opportunities. I don't know that I ever thought I would be in the position that I am now. When I was a kid, I saw Apollo 13 and I wanted to be one of those people, in mission control when I saw that movie. And now, so many years later, I'm doing safety and mission assurance, leading a team, doing the analysis to make sure we're never in those type of problem situations that they were on in that mission. So always be open to new opportunities. You never know what's going to be the right thing for you. So give it a chance, and that's what I would say.
Thanks, Helen. And to all of you, I will definitely take your advice in my career moving forward. So thank you again. So any final thoughts or remarks from each panelist that you would like to share with the audience as we close? Let's start with Helen.
So I can't express how excited I am that we're going back to the moon. And I love my job, and I think everybody on this panel would agree, right? And I hope that we can have more females, joining in our fields. And, if there are questions, I think all of us would be welcome to answering any questions folks have, because I think I'm super excited about the future of NASA and the future of space exploration.
Thanks, Helen. Nicole?
Yeah, I'll just second what Helen said. I'm so excited to see the first woman walk on the moon. I love my job. I love all of the amazing people that I work with. I'm really lucky, I think, to work within space tech and also TDM. We have the director and the deputy director, myself for TDM, and then the program and deputy program manager are all amazing, talented women. And so it's been a really neat environment to work with them and get to experience them. It's just really supportive and really, really incredible. So I've really enjoyed my time, even though it's only been a few months with them. I guess I would just say to everybody, keep staying strong. We're all in the same boat. I know what you're going through. There are some great days, and then there are some not so great days, right? Where it's like the long, slow slog of, is it over yet? Is COVID over yet? Is, when are we going back to the office? When are we going to get to travel again? I know, when do we not have to worry about our kids anymore? So there's a lot going on, but we're all in it together. You are not alone. I would just like to share that. And just thanks for tuning into our panel today. It's been really fun. We wish we could have been there in person with you.
Thanks, Nicole. Erika, anything to add?
I think the one thing I'll say is that just to kind of tell everybody, this is a really exciting time in our industry right now. Not only do we have people actively flying back and forth and still manning our International Space Station with our commercial crew and cargo partners, but just coming from the Human Exploration and Operations Mission Directorate, we have this work that we're doing now in Artemis. We're about to fly the maiden flight of the Space Launch System, with the Orion capsule, and really demonstrating, our return back to the moon. And it's not just a one-time return. We're going back to stay, right? We're going to build a sustainable presence where longer term, those are the folks that right now that are in college and that are in high school and that are in elementary school are going to be the ones helping us build our Artemis Base Camp. All these missions that we're putting together, where we're putting together a long-term infrastructure so that we can continue to build a long-term station around the moon, but also having, our robotic missions, our lunar terrain vehicle, and then our manned, science that we plan to do there in a base camp is really going to be the people that we're talking to here today as part of this conference that are going to be part of executing that. So we really need all kinds of talent to be able to make that happen. And I will say, since this topic is really about going to the moon during a pandemic, when you look at things, the moon doesn't know that we're in a pandemic, right? The hardware doesn't know we're in a pandemic, right? But we have people that are, down in Louisiana and Mississippi, going through, what's happening right now with, storms and all kinds of natural disasters, but they are still pushing through and making sure the hardware is safe, and that they're staying safe, and then still executing our missions. And it's really a testament to how resilient we are as human beings, right? That we're still being able to accomplish and take a rover to Mars, in the midst of everything that we're doing and executing all these missions. So I will say, I'll echo what Nicole says. Like, when you think back and you're like, man, this is tough, and I can't believe everything we're going through during this pandemic. At the same time, it will be a blip in the radar, and we'll get through it. And that's a lot of what the astronauts have taught us. The astronauts have taught us that this is something, they mentally prepare for, how they quarantine and how they do things. And when they come back, and it really makes me respect them even more. So just really stay positive. Just know that there's still opportunities. There's so much work out there to be done. There's so many hopeful things that we're trying to still accomplish. And so that's kind of what I wanted to leave with everyone today.
Thank you, Erica. And I really liked how you said the hardware doesn't know that we're in a pandemic, and neither does the moon. And it really shows that it's really the people at NASA and just around the world that makes this happen. It makes these missions successful. So thank you for that. Thank you again for all three of you for being on this panel today. I am honored and privileged to call all three of you my colleagues. So thank you. I'm going to pass it back to Karen for some closing remarks.
Thank you, Deboshri, and thank you again to our inspiring panelists. We appreciate all of you joining us today for this panel presentation. I hope that you found it interesting and valuable. As we wrap up, we wanted to share some additional resources on NASA's Artemis program with each of you, as you all are a part of our Artemis generation. Again, thank you, our audience, for taking the time and initiative to attend this SWE presentation virtually. On your screen, you should see a QR code. We invite you to use your phone camera to scan this QR code and take a survey on our presentation. And we hope to see you next October at SWE22 in person in Houston, Texas. Until then, be smart, stay healthy, and aspire to inspire.